All right. Hello and welcome into my channel. Happy Friday. I am doing a live stream for math. So yeah, I'll just go ahead and get into it. So I'm continuing talking about matrices and solving systems of linear equations using the inverse matrix. And I calculated this one. This was the first 3x3 I did. And I only got part of the solution. So I only found the x. I didn't find y and z. So I actually worked on this problem in my spare time and figured out the answer. And so I'm going to go ahead and fix my mistake and then hopefully plan on doing another problem in its entirety just for practice. So I felt like the first one was a little rough, and so I feel like I need practice. So with no time like the present to do some math, and Friday evening is the perfect time to do math, in my opinion. And so I'm going to spend a little while up here live on YouTube. And so if anyone is watching my stream and they want to give me a math problem, that would be pretty cool. Yeah, or if they want to come and hang out and work math with me, this is what this channel is about, and just all things math. And yeah, trying to keep it real with math. So I hope everyone is doing well out there. And yeah, so this problem kind of lengthy. I'm hoping that after I get practice that it won't be so crazy. But what I need to do first is figure out where I went wrong. So I have the solution here on my clipboard. So I'm going to figure it out real quick. And then, yeah, just get into it and see if I can't solve another one of these problems in a timely fashion. So we have our first thing I wanted to check was so this matrix of minors. I don't know why I did this, but it's because I watched a really quick YouTube video and they were doing it. I went back into my textbook and this might be like a step for a different technique, doing something else entirely, but I wasn't supposed to do this. So it looks like I should probably just redo this problem entirely instead of working another one. And then what I'll do is instead of working a new problem today, I'll probably work a new one on Monday. Okay, so let's go ahead and just get erased. And so this is a 3x3 matrix. So we're going to keep the original equations up. Make sure we have them written correctly. And then we will recalculate. The determinant was correct, but it's good practice to go ahead and calculate as well. Calculate it again, it's fine. So I calculated the determinant correctly. I made a mistake. What I was supposed to do, I wasn't supposed to multiply these by the coefficients of your original matrix. What I was supposed to do was I was supposed to apply this rule to find the cofactors. So this actually is the matrix of minors minus this scalar multiplication. Anyway, so there is a mistake in there. And that is the reason why I think a lot of people develop negative feelings about this subject, is because what happens is you do a lot of work, make one mistake, and then you get the problem wrong, and then you know it's tough. It's a daunting process to go back through your work and find that one mistake that you made, that one wrong turn that you took, and trying to correct it. It takes a lot of follow up, and it's dedication. It's Anyway, it's one of the reasons why I like it is because it's a challenge. So I know that I was able to find a successful answer. So we're going to start by taking this matrix and we're going to split it up into its coefficients. So this is a matrix of coefficients and see how I do. We've got 1, -1. I'm just listing the coefficients of my variables here. 3, 2, -1, 2, and we've got 3, 1, -2. And then we're going to multiply that by our variables x, y, and z. And then that's going to equal our constants. 3, 2, 3. So the very first thing that we have to do is we have to, the minors. So it's a matrix of minors. And you find the matrix of minors by crossing out the rows and columns that your position is working on, and then it's the resulting matrix. And then what we're going to do is we're actually going to calculate the determinants of the minors, and that's going to become your matrix of minors. So I'm going to try and fit it in here. And let's go ahead and abbreviate this. Sorry, put minors. I'll put matrix of minors. Okay, and we're going to leave plenty of room. Let's see if we can go ahead and build our 2x2s in here. Let's see if I have room. That's going to be tough. That's going to be a tight squeeze. I got to move it. So we'll just come back in. Put it here. So this is a really big matrix because it is a matrix of many matrices. So this first one, so we need a 3x3 here. So I'm going to go ahead and just put the positions in place. That way I can just fill in the numbers. Okay. There we go. A little bit there. All right. So this first column is 2y. I like having the picture right here so I can see really quickly. And then, of course, I go and watch my video later and I'm mortified sometimes about how I act up here in front of the camera. So I'm working on that. It's just a real fine balance that you have to maintain. I want to be natural and myself. I don't want to appear rigid in front of the camera, but I also don't want to be completely letting down my strings and relaxing up here. So what we're going to do is, let me get another marker. And so we're going to start with this first position, this number right here, 1. So what we're going to have to do is we're going to have to cross out the rows and columns here. And what we have left over is -1, 2, 1, -2. So that's going to be my first minor. -1, 2, 1, -2. And then we'll do this position next. So we're going to hide the middle row or middle column and first row. And I'm going to get 2, 2, 3, -2. And then we'll do this one more time with this position. So it's going to be these four numbers, 2, -1, 3, 1. We'll do that again for the middle position. Let's crossing out the second row and first column. So you're going to get -1, 3, 1, and -2. And then the middle one, you're crossing out the second row and second column. So you're getting the corners. So 1, 3, 3, -2. And then the third position here is going to be that last column, middle row. So it's going to be 1, -1, 3, 1. And then the third one here, this one, is going to be these four. So it's 1, or -1 rather, 3, -1, 2. Then this one is going to be 1, 3, 2, 2. And then this one is going to be 1, -1, 2, -1. All right, and I just want to double check that I did that correctly. I have the correct solution here, so I have it. I can just check real quick. So we've got 1, or -1, 2, 1, -2, 2, 2, 3, -2, 2, -1, 3, 1, -1, 3, 1, -2, 1, 3, 3, -2, 1, -1, 3, 1, -1, 3, -1, 2, 1, 3, 2, 2, and 1, -1, 2, -1. Perfect. All right, so I have it. And so what I have to do now is I have to calculate all of these determinants. And it's going to give me a matrix of minors, essentially. So where do I want to put it? Maybe right below it. Put it here. So we're going to do a 3 by 3, and then we're going to figure out the determinants. So the determinant is found by doing the diagonals. So you're multiplying the diagonals and subtracting them. So this first one, -1 times -2 minus 2 times 1. That is +2 minus 2 equal 0. So this first position is 0. And then this one, we've got 2 times -2 minus 3 times 2. So that's -4 minus 6 is going to give me -10. So this position is -10. 2 times 1 minus 3 times -1 is going to be 2. -3 times -1 is +3 is going to give me 5. So this one's 5. See if I can fit one more here. We've got -1 times -2 minus 3 times 1. So that's going to be 2 minus 3 is going to give me -1. And then this position, we've got 1 times -2 minus 3 times 3. So that is -2 minus 9, which is -11. And we've got this one here, 1 times 1 minus 3 times -1. So that is 1 plus 3. It's going to give me 4. So this one's 4. And we've got 3 more left. So we've got, so we did those, did that one. We're here now. A -1 times 2 minus -1 times 3. So -1 times 2 minus -1 times 3. And that's going to give me -2. And then 2 negatives are going to make a +3. So that's going to give me 1. So this position is 1. And we've got a couple more. It's this one. So we've got 1 times 2 minus 2 times 3. So this is going to be 2 minus 6 is going to give me -4. And then we have 1 times -1 minus 2 times -1. So that's -1 plus 2. They're going to give me 1. All right. So here's your matrix of minors. And I will just double check that I calculated it correctly. 0, -10, 5, -1, -11, 4, 1, -4, 1. Perfect. So here's your matrix of minors. So there is a formula for calculating the cofactor matrix. And what you're doing is, depending on the rows and columns, you use the formula. So for a 3 by 3 matrix, you're going to use this for cofactors. And this is just a shortcut. There is an actual formula to calculate cofactors, but if you're not a math major, you're not going to appreciate it. So that's a lot of negatives, but I feel like only a math major would actually appreciate the formula because there's so many subscripts. And so what I'm going to do is I'm just going to write it in here. So you're going to use cofactors according to this pattern. So you're just alternating signs starting with the positive. And then you'll continue this pattern out. And this is the way it works out. So what I'm going to do is I'm going to rewrite this matrix using the cofactors. So we'll have a resulting matrix here. And then it's going to be, actually, I'm trying to make it a little bit smaller so I can fit 2 of them in there. So we'll have this one. So I have 0 is a positive, so it's just 0. -10 is negative, so that makes 2 negatives make a positive, so we're going to switch that one to positive. 5 is already positive. -1 and times -1 is going to be a +1. -11 is already negative. It's going to stay negative because it's positive. And then we've got this, a negative times 4 is -4. And then 1 is already positive. It will stay positive. Negative times a negative is a positive. And then you got a positive is already positive. So here is your cofactor matrix. We'll start it. Now, what we have to do is we have to transpose this cofactor matrix here using this rule. So you use the diagonal, that diagonal stays. This is transpose. We'll just say transpose. Okay. And what we're doing is we're swapping out the diagonals along the diagonals. So we have 0, -11, and 1 is going to stay. And 1. And then we're going to swap out 1 and 10. So 10 and 1. 1 and 5. And 4 and -4. So here's our transpose. What we have to do now to calculate that inverse, so let's write that inverse formula out. So for matrix A equals A, B, C, D, A inverse equals 1 over the determinant of A times the adjoint of A. So this is the adjoint of A. Okay, this right here is the adjoint. So all we have to do now is multiply it by the determinant of A. We could recalculate that determinant. If I do, I'm going to put it here. So I'll erase these. This is just my scratch work anyway. So the determinant, so we'll list that up here. Determinant. You're going to list your original matrix here, and then you're just going to copy the first two columns. So we've got 1, -1, 3, 2, -1, 2, and 3, 1, -2. And then what we're going to do is we're just going to list those first two columns. So it's 1, -1, 2, -1, and 3, 1. And then what you're doing is you're just doing the diagonals. So it's this diagonal. So it's going to be 1 times -1 times -2 plus this one. So it's -1, 2, and 3. Plus this diagonal, which is, what was that, 3 times 2 times 1. And then we're going to go the other direction, and we're going to subtract the other diagonals. So it'll first begin with these 3. So it's going to be 3 times -1 times 3 minus this diagonal, 1 times 2 times 1, and minus one more, this one. This one is -2 times 2 times -1. Okay. And we'll simplify that. So we have 1, -1, -2, that is +2. And then we have plus -1 times 2 times 3, that is -6, plus 3 times 2 times 1, which is +6. And then we have minus 3 times 3 is 9, times -1 is -9, times a negative is +9. And then 1 times 2 times 1 is 2, and it's a negative, so that's going to be -2. And then 2 times 2 is 4, negative, times -1 is positive, and then it becomes negative again. So we got -2 and -4. So we've got all this. So this is 2 plus 6 minus 6 plus 9 minus 2 minus 4. So those will cancel, and you've got 9 minus 4 equals 5. So the determinant is 5. So we'll star that. So per the formula for calculating the inverse of A, we want to put the determinant over 1, and we're going to multiply the adjoint of A. So the adjoint matrix is this one. So this is the one that's going to get multiplied by the scalar 1/5 per the determinant. So we have this matrix times 1/5, the scalar. Right here. We'll just do 1/5 and then we'll calculate it and rewrite it out. So we'll just switch that. So 0 times 1/5 is 0. 1/5 times 1 is 1/5. And we have 2 of those entries. And then 10 times 1/5 is 2. 10 divided by 5 is 2. And then this is -11/5. And then we have -4/5. And then 5/5 is 1. And then this is a -4/5. And then that last one, 1 times 1/5. 1 times 1/5 is 1/5. All right. So let's just double check, make sure I'm still doing good. So we've got 0 to 1, 1/5, 1/5, -11/4/5. Wait. This right here is positive. So I don't know how I snuck that negative in there. It's not negative, it's 4/5 positive. Okay, good. And then, okay, that was the only mistake I saw. It's because this is positive here, so positive 4 times 1/5 is positive 4/5. Okay, so this is your inverse. So this is a inverse of 1. So this is the inverse. Okay, that is the inverse right there. So all we have to do per this formula is, so you have x, y, z equals your inverse, which is this 0, 1/5, 1/5, 2, -11/5, 4/5, and 1, -4/5, 1/5 times your constants. 3, 2, 3. So when we're multiplying matrices, remember it's rows times columns. So this is a 3 by 3 times a 3 by 1. And so your resulting matrix is going to be a 3 by 1. So what we're doing is we're just taking the row 1, column 1 here, and we can do it here pretty quick, I think. So it's going to be 0 times 3 plus 1/5 times 2 plus 1/5 times 3. And really, I need more room, I think, to work this out. Maybe we'll sneak it in here. 0 times 3 is 0. 1/5 times 2 is plus 2/5. And then 1/5 times 3 is 3/5. So we have 0 plus 2/5 plus 3/5. That's just 5/5, which equals 1. So for this first column, x equals 1. So to find the second column, we're going to use the second row and multiply it by this first column here. So it's going to be, we can do it here, we'll scoot over. It's going to be 2 times 3 plus -11 times 2, -11/5 times 2 rather. 2 plus 4/5 times 3. And so we have 2 times 3 is 6 plus -11/5 times 2 is -22/5. And 4/5 times 3 is 12/5. So we have 6 minus 22/5 plus 12/5. So what we're going to do is we're going to subtract the numerators here. -22 plus 12 is -10. So we have 6 minus 10/5. 10/5 is just 2. So that's 6 minus 2. 6 minus 2 equals 4. So here is our y value. So y equals 4. And then see if I can sneak this last one in here on the bottom. We've got 1 for z. We got 1 times 3. So let me erase this. So that is 1 times 3 plus -4/5 times 2 plus 1/5 times 3. And 1 times 3 is 3. -4/5 times 2 is -8/5. And 1/5 times 3 is plus 3/5. So we've got 3 minus 8/5 plus 3/5. So we're going to combine these fractions because they have the same denominator. -8 and +3 is -5. So it's going to be 3 minus 5/5. So it's 3 minus 1, which is 2. So z must be 2. So we can see that we already had our solution here. So this is x, y, z. So x is 1, y is 4, z is 2. Perfect. Checks out. All right, so this was my redemption from yesterday because I do occasionally make mistakes, and so a little redemption on Friday evening is not a bad thing. I am not going to complain about that. So we'll go ahead and stop there and call it good. And since I was able to successfully complete this problem, I may try to do one that's pretty straightforward on Monday, just for like not a speed run, obviously, because I'm so slow, but see if I can do it a little bit faster. Okay, that's the goal. Anyway, if you watch my video, thank you very much for watching and supporting me anyway. And I really appreciate it. It means a lot to me, believe it or not. And I do want to eventually be able to help students on this platform. So we'll just see how it goes. I'll manage my expectations in the meanwhile. So I just want to say that I hope everyone has a wonderful weekend. And yeah, I will be back on Monday, same time, same place for now. And so I'll just say, I'll sign off and say bye for now, and I will see you all next time. Bye.